In this video, we're going to look at scatter plots, how to create them, and how to use them to identify trends in data. The specific data we're going to work with is, in this case, data set from Kaggle on Bitcoin prices over time. Once I download this as a CSV, I can load it into Google Sheets using the import utility. There's an option here to upload data. Since I happen to have my CSV already handy, I'm going to drag this here, and you'll see it automatically detects data types, or at least attempts to. The resulting spreadsheet looks like this. I'm going to do some quick and dirty formatting just to set my headers to make them a little more visible. Do some centering. And what I like to do is freeze the top row. Under View, you can freeze the top row. That way, if I scroll down using my scroll wheel, the header row, the row number 1, stays in place. Now, as you can see, column A consists of dates. All of this is coming from plain text, comma-separated value file. So if I want this to look a little nicer, I can highlight row A, format it as a number, and from that choose date. I like this. It looks a little prettier this way. And as you can see, the values for the different columns, opening, high, and low, and closing, as well as the adjusted closing, these are numeric values with 6 digits after the decimal point. I'm going to leave them in place as is. The final volume, the volume traded in column G, that's a big number, total number of Bitcoins traded that day. I'm going to change the format of this just a little bit for visual purposes. Use the comma-separated values. That way I can identify how many millions and thousands and so on. Otherwise, the formatting for this looks pretty good. I'm going to scroll down through this just to eyeball it, see if there are any notable outliers or erroneous records. And it looks pretty clean. I think if I get to the bottom here, I start to find a few rows in which there are no values at all in any of the columns. Those rows are not going to be useful in the visualization because they represent the lack of information rather than actual numbers. So what I'm going to do to clean that up is I'm going to select all data with Control A. I'm going to sort this. Under Data, you can choose a sort range. And you'll notice by default the sort range is listed with column A, B, C. If I tell the Google Sheets that my first row is a header, then that sort by list now defaults to each of the labels in row 1, which is nicer. I'm going to sort them by opening value in descending order, just because when I do that, I think that's going to cause those nulls to sort to the very top. Let's take a look. There they are. Now I see these first 4 rows, when it's sorted this way, don't contain any useful value. So what I'm going to do is remove them from the data set by highlighting them and then right-click, delete. Now I'm going to re-sort my data, select all, Control A, Data, Sort Range, and put it back in value by date in ascending order. What we end up with, as you'll glance at this, you can see we have the earliest record is September of 2014, and this goes all the way down to the most recent records well into 2021. Those are values up to August 10th. Very useful information. Now, let's try to make some visualizations from this. But before we do, I'm going to add a couple of columns using calculated values. Over here in column H, I'm going to calculate the percentage change from the previous day. This is something I did in the last video, the retirement savings visualization, by essentially making a formula. And we're going to use the closing values, the closing volume values, going to set the percentage change equal to closing value minus previous day's closing value, subtract that result by the previous day's value. What we get is a number here, and as with the previous video, there's a suggestion: would you like to autofill the remaining columns, the rows in this column below? And I do want to do that, but I'm going to change the format of this column to a number percentage. That way we can see for each of these rows, all except the very first one, for which I don't have any previous day's data, but for all subsequent rows, I can see the percentage change of the closing value over the previous day's closing. So when that drops a bit, we can see a negative percentage. When it comes up, you can see a positive percentage. There's another pair of columns in here. We have highs and low values for the day, which is interesting. Gives us an idea of how much this will fluctuate. What I'd like to do is also create another calculated value in column I that I'm going to call range, and that will be equal to the high value for the day minus the low value for the day. And yes, I would like to populate all subsequent rows below. This will tell me in a numeric value that will indicate how wide of a variety of that will indicate how wide the values fluctuated during that day, the high point minus the low point. And I can reasonably expect this resulting number to always be in the positive, because the high should always be at least as low, at least as high as the high, assuming this data is accurate. So now we have a couple of additional calculated values, the percentage change for the day and the range of fluctuation for the day. So let's look at some visualizations we can create from this to look for trends in the data. I'm going to start by simply highlighting column A, which is date. I'll hold down the Control key and highlight column H, these two columns. So I have pairs of values, one for the calendar day and the other for the percentage change of the price of Bitcoin for that day. I'm going to add a simple chart, which by default will pop up here in my current sheet. I'd like to move that somewhere else so I can have a little more room to work with it. It doesn't get in the way of my data. So if I click these little three dots here, there's an option for Move to Own Sheet over here. And I'm going to rename this sheet as percentage change over time. This will give us a visualization chronologically on the x-axis with the days starting in January, around January of 2015, a little bit before then, and going into recent months in 2021. For each of these days, we can see the percentage fluctuation in value from the previous day. Sometimes these are positive, greater than 0. Sometimes they're negative, lower than 0. And we can see that at certain times, those range fluctuations seem to be wider than others. In 2018, this time or period around here, there was some pretty wide highs and lows in fluctuation. And then one significant dramatic drop here, which is the early months of 2020. Guess that's, I wonder what caused that. That's probably, it happens to coincide right around the time of COVID. So I'm going to make a guess, although I can't assume that correlation equals causation. But since that happened around the same time as COVID, that's I'm going to stick with that answer. It's probably due to that. But otherwise, we see a general fluctuation, no major trends. We have ups, we have downs, and these kind of balance each other out overall. So that tells us something. We can see some sort of fluctuation over time. I'm going to make another chart here. And let's look at our range fluctuation. That's the number that represents the difference between the high and the low for the day. Likewise, Control, and I'll make another chart on this just to look at the correlation of range fluctuation over time to see if I can find anything that coincides with the previous visualization. Insert chart, which again pops up here. I'm going to choose this move to own sheet, push it over here, and whoops, push it over here, rename it, call this range over time. And as with the previous graph, we can see the x-axis is chronological dates from 2014 through August of 2021, and we do see high fluctuation values spiking in 2018, lowering back down for a while. A few fluctuations here and there. In the early months of 2021, we see much wider variation. Great big spikes here in difference between the highs and lows. We don't know what that means yet. We might not know, but it tells us that something was going on in the daily highs and lows in recent months. This is the beginning of 2021. If we correlate that with the previous graph to look for anything going on in terms of percentage change in the actual price, we don't actually see. If you cycle between these, you'll see that the grid lines for the chronological x-axis are the same. So if we see spikes here, we might look to see if there's a similar fluctuation in the other graph. I don't see anything in terms of the actual ending price, the change from the previous day's ending price. Don't see anything really wide that sticks out for these months, the early months of 2021, anywhere near like the range fluctuations we're seeing here. So, coming up dry so far, but that's how the process works. The next thing I'm going to try is to see if there's any correlation between that percentage change and the range change. These two calculated values here. Now, if I'm only looking at these two, and I'm ignoring values over time, a linear graph is not necessarily the most appropriate thing for this. What we want to use is a scatter plot to see for these pairs of values if any trends jump out at us in the resulting visualization. That's how scatter plots work. They work on pairs of values, and each one of those is graphed as a series of x and y dots. And if those dots line up in a line or a curve, that tells you something about the data. So if we compare pairs of percentage change from previous day with the actual fluctuation over the course of the day, we can insert a chart. I'm going to change that from line chart, which obviously doesn't make sense for this type of data, to scatter plot. And I'll move this to its own sheet, again to make some room. We'll label this one change versus range. Question mark. What we end up with are a series of x and y dots, plots, that indicate pairs of values between the percentage change for the day, which is sometimes in the negative, sometimes in the positive. Here's the center line. And the percentage, not percentage, but rather the amount of fluctuation, the high versus the low in values for that day. What we end up with here is a big blob. I don't see a line. What I see is a more or less symmetrical series of dots in which the days ending in negative change and the days ending in positive change seem to behave roughly the same in terms of fluctuation. There are outlying values where the percentage change was really low or really high, but I don't see too many, I don't see anything that indicates a major line or curve here. So we'll continue. Let's try comparing change versus volume. Here's our percentage change. Here's the volume of trading for the day. Maybe on days when there's particularly high volume of trading, maybe the percentage change will fluctuate higher or lower. It's possible that lots of trading will result in really high profit, or vice versa. So let's try making a scatter plot from these. Insert a chart, change it to scatter plot, stick this in its own sheet. I'm going to label this one change versus volume, question mark. Because again, we're looking for some sort of trend. And what I see here on my x-axis, I have the amount of trading for the day. That is to say, values to the right indicate higher numbers of bitcoins purchased and sold. And the closer we get to the left, the lower those values get. And the y-axis, we have the percentage change in price for the day. And once again, we have more or less a symmetrical collection of dots. I don't see a trend anywhere. I see on days with high trading, you had some gains and some losses. On days with relatively low trading, you had some gains and some losses, but nothing jumps out in terms of a pattern. That's the point of a scatter graph, is that we can look at these points and see if we can identify some sort of linear or curve pattern. And so far, we're coming up dry. Let's try one more combination. This time we'll compare volume and range. Volume as in the number of units traded, and range meaning the difference between high and low. One more scatter plot. Move to its own sheet. I'm going to call this one volume versus range. Now, this one starts to look interesting. We don't have too many outlying values here. There's a few oddball points that are way out of the range of the others. But what we tend to see here is that in the days of low trading, where the number of bitcoins traded is relatively low, the resulting range, the difference between highs and lows for that day, seems to be relatively low. And as there's an increase in volume of trading, there seems to be a general increase in the range of highs and lows. This sort of line that tracks out here gives us a hint that there is a correlation between these values. This is what you're looking for when you make a scatter plot. This sort of pattern, where an increase in one appears to cause an increase in the other. Now, I wouldn't say this is anything remotely like a straight line or a clearly defined curve, but the general pattern does show to us, when we compare these pairs of values, that there's some sort of correlation between them. That's how scatter plots work, and that's their value.